at example number 3, which is the last one now. You should be comfortable now. I really believe so. So let's say now we're given you a word statistics. Okay, you know our procedure. We count number of letters first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what do we have? We've got 10 letters. We look at repeated letters. So we can see that we've got S repeated. So 1, 2, 3. So 3 S's. Also have T repeated. 1, 2, 3. 3 T's. Also have repeated I's, which is I and I. So we've got 2 I's. So this is a good example because now we no longer have only one repeated letter. Okay, first question, how many possible arrangements it can be made? That's going to be normally your first question. How do we do it? Straightforward there. Once you've broken it down like that, it's very easy. I use has for number. Number of arrangements would be number of letters, factorial of that, 10 factorial divided by repeated letters. We've got 3 S's, 3 factorial, times we have 3 T's, 3 factorial, we have 2 I's, 2 factorial. Then if you punch this in your calculator, you'll get 50,400 different arrangements or different weights that can be created. Then the next question, they are saying find the probability that the arrangement starts and ends with a vowel. Okay, let's underline starts and ends with a vowel. Okay, let's look at different cases that we can get there. So let's look at how many vowels do we have first. So looking at our vowels, we have A and I. So we only have one I. Then we have 2. How many A's? 2 I's and 1 A. 2 I's and 1 A. Okay, so starting with the vowel. So there are different cases. So 1, we can have it starting with A and ends with A because we've got 2 A's. How would that look like? Or we'll just leave it like that. And then case 2, start with A and, so if it makes sense, I should put this down maybe. Should just write it like this. So I've got 1. So we have 1, 2, 3, 4, 5, 6, 7, 8. How many? 8, 9, 10. So we are saying here we are starting with A and ending with A. That is case 1. Case 2, we have 10 slot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're now starting with A but ending with I. So starting with A, ending with I. And the opposite of this is true, starting with I and ending with A. Of course, with here A and A, they are the same. So we can't say starting with this A and ending with that A, or starting with that A. Like we can't swap because they're the same. But here it's A and I, so we can start with A and ends with I, or you can start with I and ends with A. So remember here we have or, very important, because or means that you're going to be adding this or. Let's look at how many possible arrangements here. So we're left with how many letters now? 1, 2, 3, 4, 5, 6, 7, 8. So 8 letters is going to be 8 factorial over repeated letters. We have 2 I's, 2 factorial. Looking at case number 2, arrangements here, we're going to have 8 factorial again, but to have repeated letters, no, because we've used I. Here is fixed. We're left with 1 I here. It's going to be used somewhere here. So we're not going to divide by anything. And then actually, let's go back. So I missed that we have got 3 S's and 3 T's. So here we must say 8 factorial divided by 2 repeated I's, 3 repeated S's, 3 repeated T's. Don't forget what is above. So now I just ignored this. she's wrong. So on the second case, we have 8 factorial divided by repeated letters, which is S's and 3 T's. But now with I's, we have one I here. It is fixed, so left with one I, so we're not going to have 2 factorial. In the last case, it's going to be the same as this one. 8 factorial. Don't have 2 factorial because we only have one I now. Okay, and then so the total. So the probability is now gonna end up being, or the number of arrangements is going to end up being what we got here plus this plus that, which is 8 factorial over 2 factorial times 3 factorial times 3 factorial plus that, which is the same, so it's just 2 times this plus 2, it's a different color, times 2, 8 factorial, 3 factorial, 3 factorial, which ends up being 360, and then the probability I'm late to write this, but if you like, I can just call it A. Number of arrangements A. So basically we are saying A is an event that starts and ends with a vowel. So if I note that this is what we are defining A to be, we don't have to write this long statement every time. We should be number of events in A divided by number of events in a sample space, which would be that divided by all the possible outcomes, which was 50,400.